Okay. All right. So, thank you for your flexibility in meeting online today. We'll take a look. I wanted to today I want to introduce Seaborn, which is another data visualization library, kind of like it's built off of Matplotlib. I did want to just kind of go over a few more things in Matplotlib. We didn't cover a lot of stuff in Monday's lecture. But I do want to kind of especially just go over some of the Matplotlib integrations with Pandas data frames, especially just because I think that's, for me, in my opinion, that would be the most compelling reason to learn, some of the things in Matplotlib is because it is so well integrated with Pandas. So I still have lecture 6-1 open right now, and I'm scrolling towards the uh, bottom of the notebook. And so here I'm just kind of producing a an arbitrary data frame where this is, you can imagine two different categorical variables with different numbers in here. And so if you have it, if you have a data frame arranged in this form, you can create um, a bar plot, kind of a side-by-side bar plot, and that can be done just by calling the name of the data frame dot plot dot bar. Okay, and what this will do is it will automatically create a bar plot from this. And so let me go ahead and execute that. And so its default form is to put the index along the x-axis, and then put the column headings. Okay, the column index becomes the different colors within the bar plot here. Okay, so as far as the different side by side things, so you can kind of see, you know, tech. Um, for tech, California has a height of 5, New York has a height of 3. Texas has a height of 8, or so on. Again, these are just random numbers that I made up, but it can get plotted that way. If you want to swap them and you want to put the states across the x-axis and put the different kind of economic sectors as different colors, you would just transpose the data frame, and there that's going to put the column headings down the axis, and then these current row names will become column headings, and then you call dot plot dot bar. Okay, and so that uh, does that makes that change. Okay, um, just like any of the other things in Matplotlib, if you uh, if you want to change things before you call plt.show, okay, you can add options like the title. You can change the position of the legend. You can change, axis labels and things of that nature if you need to. So here I'm changing the position of the legend so that it's not showing up kind of in the middle of the plot here, which for whatever reason is the default settings for um, the plot, which I don't know. That's what they've done. Um, and then if you don't want it side by side, you can change some of the options as far as the plot. You can do plot.bar stacked equals true, and uh, you'll get the corresponding plots. Instead of things showing up side by side, you'll get the different colors stacked up. All right. Here's just another example, taking a look at the Titanic data set. Okay, so I'm just loading this up, and so again, the Titanic data set has a few different variables. We have things like the passenger class, the sex of the passenger, so on and so forth, whether the passenger survived or not. And so if you just do take the column survived and do dot value counts, then you'll get a series with the counts of zeros and ones and things like that. Okay. And so once you have a series in this form, you can then plot it. Okay. So all I'm doing is I'm just chaining all of these things. So we're taking the data frame, we're selecting the column or the series survived. From that, we are creating a summary table using value counts. That in of itself produces its own series. And then from there, I'm just calling plot. Okay, and plot kind equals bar is going to produce this. If you don't specify kind equals bar, um, you get you get a line plot, which is probably not helpful. So it says, oh, because here it's basically treating zero as it's treating this kind of as coordinates. Okay, so you get 0 and 549. I think you can even do depending on what you have. I think scatter is the option. No, scatter can only be used for data frames. Okay, so. Um, okay, but anyway, kind equals bar is probably what you would want in a scenario like this. Okay. Let me see here. All right. So the data types. Okay, so we have um so one thing is that right now the survived column regarding whether the passenger survived or did not survive is currently stored as an integer, 0 or 1, which, we can understand how it works that way, but you can also you might want to convert it, okay? And so here I'm taking Titanic.survived and I'm going to do as type category. And let me just kind of show you what that looks like. Okay, so it doesn't look like anything has changed, okay? But it says there's two categories, 0 and 1, okay? And now it says D type is category versus if I just have the survived thing, it just says D type int64, okay? So by doing as type category, um, we are going to take the survived column and then convert it into a category data type, categorical data type, and then store it back in our data frame. Okay, so in pandas, as type category is pretty much like in R you have as a factor, and then in Python pandas we have data type category here. Okay, um, data type object is like string data. Okay, and or character data. Yeah, category would be like a factor. And then when you have a categorical variable, category factor, there are options like renaming the categories and things like that. And so here I provided a little dictionary and says 0 means they're going to die, they have died, and 1 means that the passenger survived. So here I'm taking that and I'm renaming the categories. And then so now, um, if I take the if we look at, let me just show you what Titanic dot survived looks like. Okay, so rather than zeros and ones, now I actually have names here. Okay, so we've renamed the categories, and so now I can create summary tables. Okay, so I could do value counts. Okay, and then we'll get basically the same information as before. Survived and died here. But now we have looking like this, value counts, and then I could do a plot, kind equals bar. And then now that I've renamed the categories instead of 0 and 1, it uses the label that we've used, died and survived. Okay. Um, in pandas, you can also take two categorical variables, okay, and you can create a cross tab. Okay. So I can take the variable sex, which currently has male or female in there, and then we can take the categorical variable as far as survived goes, and we can create a crosstab. And what this will do is it creates basically a two-way table, and it breaks everything down. And then now that I have this, okay, so again, all I'm doing is I'm just chaining all of these things together. So we're going to take pandas, crosstab, creates this table, and then from this table, which itself is a data frame, I can create a plot. Okay, so basically we're doing the same thing that we did back here where we have a data frame and we're just saying create a plot here, but this time it's uh, based off of a data frame that we've created here. Okay, so I can do plot like that. I think I can even do, I think I can do plot.bar in the same way. So we can do this, yeah, plot.bar, and then I think we can do, is it stacked equals true? Or no? Yeah, stacked equals true. So you can do plot.bar, or you can call the plot method directly, and you'll do plot kind equals bar, stacked equals true, and you'll get the same kind of thing here. All right. So now we can see as far as so this kind of brings attention to, at least in the Titanic data set, kind of the notion of saving women and children first, going onto the lifeboats, and you can see that there is, quite a difference in the ratios of those who survived and did not survive. Um, it's a big major split between the sexes there. Okay. Um, as a child, I don't know. I just arbitrarily selected an age of under 8. So, young children, I guess, is a young child, maybe, perhaps, is uh, maybe a better name here. Titanic is a young child. And then so here I can create what this will do is this will take that age column and then create true false variables, store it as a new variable, is child. Okay. So we're basically creating a new column. In this case is child here. And then we can create a crosstab and we can have false and true here, whether as far as they are a child or not, and then did they die or survive? Okay, and so if we plot this, so one is there weren't very many young children to begin with, um, but I can take this crosstab and I can, um, oops. We can plot it. Okay. Another thing that you can do when you create a crosstab is you can call this option normalize. Okay. And what normalize will do is uh, it will convert everything into proportions. Okay. So we can see um, the proportion of children that died and survived, or I guess proportion of young children that died and survived versus the proportion of non-young children that died and survived, and so on and so forth. So here, if I have this normalized, then I uh, have the proportions, and then now we can create a stacked bar plot. Okay, and the stacked bar plot, now that it's proportions, um, the heights will add up to 100%. Okay, or a proportion of 1.0. So we have that. Okay. Uh, Similarly, I can create here, I'm creating a summary table, and we're saying group by uh, the variable sex, is child, and survived. Okay. And then we're going to count how many uh, individuals exist in that thing. Okay. So here I'm creating kind of a hierarchy of groups. Okay, so we now that I've done this, we've got sex, female, male, sex is child, and in your brain you should think of as is a young child, and then survived versus died here. Okay, and then um, now that we have this series like this, I can unstack it. Okay, and what that will do is it will unstack died and survived into these different columns, and then from there I can create a bar plot. Okay, so we're just taking this, we're unstacking it. We are going to create uh, a plot based on this, and we can see we have female is not a young child, female is a young child, male not a young child, male is a young child. The counts are all kind of hard to normalize just because the counts are so wildly different. But anyway, we have that. You can um, regarding the unstacking here, when it unstacks, it usually unstacks the innermost uh, kind of hierarchy. And you can say, well, I want to unstack um, uh, at a higher level. Okay. So here I'm taking Titanic summary and I'm saying, oh, I'm sorry. So let me just do unstack. This is what we get. And then I'm going to say, create a sum here. Okay. Along axis one. So this is summary.unstack looks like this. We have the died and the survived here. And then as far as summing along the axis here now, we're just getting the counts of whether they survived or died. They just get added together. So we can say how many young female children were there, okay, regardless of survival. Okay. There were a total of 24, 6 and 18 make 24. Six of them died, 18 of them survived. And we can say, create a sum here, and we get a total of 24. So I'm going to just kind of take this, um, store this as the row totals. Okay. And then now we're going to take those row totals in order to kind of um, get the total, the proportions. So, pandas requires a little bit more kind of maneuvering here. So again, here I have Titanic summary unstacked. Okay. And then I'm going to take these things, which I'm storing as row totals, and I can take this data and I'm going to call dot divide, and we're going to take these numbers and divide them using our row totals. Okay. And what this will do is it will calculate the proportions. So we can say, all right, 6 divided by, so as far as female young children, there are a total of 24 of them, and we can say 6 divided by 24 is going to correspond to 25%. 18 divided by 24 is going to correspond to 75%. And we can do that for each of the different rows here. We're going to divide by the row totals. All right, and so now I have proportions here. And now that I have proportions, I can create a stacked bar plot where the heights of the bars have been normalized so that the proportions are all kind of like around 100%. Okay. So, so over here, it's really hard to kind of see the difference because here you have such varying counts of, adult or non young children who are female and young children who are males, and males who are not young children and females who aren't young children and things like that. But now we've kind of normalized them. And so this reveals something kind of interesting is that as far as the survival rate of women, okay, the survival rate of women who are young children or girls who are young children and women who girls and women who aren't young children, their survival rate is similar. But then regarding males, the survival rate of those who are young children and those who aren't young children, there's a very kind of drastic difference here. And so this, reiterates kind of the stories that we hear regarding the Titanic of, saving women and children first. If it was a young child, uh, young male children have had a higher survival rate. Young female children had a high survival rate. But then as far as non, ones who weren't young children, the high survival rate for the women, but not for the males there. Okay. So that's um anyway, these are just some of the steps that you have to kind of go through using pandas and matplotlib. So a lot of um you can take a pandas data frame and call plot on it directly, plot kind equals bar or whatnot. But you do have to kind of think in your head like how to kind of maneuver about to get the data frame to look like the way you want it to be. Um, Here, let me give you your first view quiz answer for today, which is the letter B. B as in bear is your first view quiz answer. Okay. All right, this is just another data frame where I've taken kind of like random dice rolls. So I said, all right, let's simulate random dice rolls. And so here I took random numbers and then 1 through 6. And then um, and then I said, okay, what if you took two dice rolls and you add them together? And so DF2 is taking the values from DF1, and then we're adding more random integers. Okay, so column one is just, let me just kind of show you actually what uh, the DF looks like. Okay, so column one is just one random dice roll, 1 through 6. And then column two is if you took another random dice roll and you added it to column one. So this would be like we rolled the number 5 and we added it to 4 and we got a 7. Here's a 6 and we rolled the number 1 and we happen to get a 7. Here we happen to roll a number 4 and we added it to a 3. And when you add that together, you get a 7. And so what we see is we see the distribution there. And we get kind of this triangular shape here. This is, we're calling create a histogram. So from the data frame, you can say, I want to create a histogram based off of this. Um, and so we're going to do plot.histogram, and we're going to say bins equal 12, alpha equal 0.5, changes the kind of the transparency so we can see the kind of both shadings here. So we have that, and we get this triangular shape. This is very much. Let me see. Dice roll distribution. It very much reflects this. There's only when you have two dice, there's only one way to roll a 2, whereas to roll a 7, there are 6 unique combinations you can get. 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. Okay. And so, we're seeing this shape regarding the actual possible way combinations to get that, and that shape gets reflected in our histogram as well when we do random dice rolls. And we can kind of continue to do this, and I can say, all right, go ahead and take another random dice roll, add that, and then what is your total dice roll after 3 dice rolls? What is it after 4 dice rolls? What is it after 5 dice rolls? Okay. And if we plot that, then we start to see the effects, the central limit there. You start off with um, a total number of, a uniform distribution, then a triangular distribution in each of these things. It's maybe with all of the shading, it's tough to see, but you can start to see that, by the time we have five dice rolls together, the distribution starts to resemble the normal distribution there. Okay. Anyway, these are all just based off of um, again, here I'm taking the data frame. The data frame looks like this. I've got different columns. And as far as some of the different calls that you can make, you can just call plot. And in this case, we're going to do plot.histogram, plot.hist. Okay. The default options of plot.hist will end up looking like this, which isn't great. Okay. And so you can change the number of, say, bins, increase the number of bins, and you get something like this. And again, I mean, this is and the issue here is that you can't see the the histograms behind it, right? So this is why I have alpha equal to 0.5, which changes a little bit of the transparency there. Okay, so anyway, that's Matplotlib, and there's the rest of the notebook covers a lot of the other stuff. But again, I think the most useful part of Matplotlib is that it integrates well with what do you call it? Pandas. Okay. All right. As far as creating plots in Python goes, another library that we like is Seaborn. Okay. And so Seaborn a is built on top of Matplotlib, and it creates a lot of kind of useful plots, useful data visualizations, um, and they're kind of queued up so you can kind of do some quick plots that are helpful, kind of nice and pretty. And so anyway, we'll go ahead and take a look. I'm gonna clear these outputs and restart the notebook here. All right. Okay. So we're gonna load up NumPy, Pandas, Seaborn. When we import that, you might have to do a pip install Seaborn if this cell produces an error. In your terminal, pip install Seaborn. Um, for whatever reason, we import Seaborn as SNS. That's those are the that's the shortcut we use. Okay. Let's see. My Seaborn version is 0.13.2. I think there's a later version. It's good enough. Okay. We'll use the Penguins data set. That is, it's already kind of loaded in as with the Seaborn data, and you can load that up using sns.loaddataset penguins, and I can kind of take a look at this. And again, we have the Adelie penguins, and I think they're Chinstrap and the Gentoo from the different islands, and we have bill length and bill depth and flipper length and body mass and things like that. Okay, so one of the kind of basic and helpful plots that we have is we are going to do the distribution plot, okay? And this is the Seaborn SNS dist plot. And so you'll see a couple things going on. We got SNS dist plot, but again, Seaborn is built on top of matplotlib, so when we're done, we're going to call plt.show, which is the command we use in matplotlib to show the plot that we've produced. All right, and so kind of um, all we're going to do here is we're going to just pick one of the variables, okay? And I'm going to do flipper length, which is this column right here, flipper length in millimeters, and so I'm going to say our data is our penguins data set, and we're going to select the column flipper length flipper length millimeters. And this is basically going to create like a histogram, okay? And this is what it calls a distribution plot. Um, so in my opinion, and I think the goal of Seaborn was to create plots with default settings that are generally, nicer than Matplotlibs. So again, with Matplotlib, if I picked one of these things, like if I did DF, what was the thing called? I think, if I picked the column 5, I think I can call this. So this is the default settings for a histogram in Matplotlib. Um, Over here, if I do sns.displot, data equals df and x is equal to 5. Uh, okay. Yeah, so this is the default setting as far as the plot goes. And oh, I guess what it's kind of emphasizing the discrete nature discrete nature of the plot here. Okay. Of the data, which is true that we don't have any like 15.1s or anything like that. Okay. But anyway, Seaborn, as far as the uh the, the defaults go, is generally the defaults do an okay job. But again, you can change any of these things. So we can say, hey, I want different numbers of bins, and then we can add what's known as a rug. Okay. And what the rug will do is it will add little tick marks showing exactly where those values are located. Okay, so here I'm increasing the number of bins, and we can see the actual tick marks for where the different observations are. Okay, you can also, instead of how many bins you want, you can change the bin width to some number, and I can say, "Hey, I just want two values in each one, and we'll have a whole bunch of plots there. All right, so each bin here represents, two values or something like that. We have that. Okay. You can also specify cutoff points for the different bins. So here I'm setting up tick marks. And so notice this thing, I'm going from 170 up to say 200, and then I cut it off there. So this is going to truncate the plot, and we're not going to get anything over 200, despite my data going up to 230. Okay, so here we can create custom bin points as splits as well. So these are all different options that you can do. If you want to add a smooth curve, which we would call a kernel density estimate, a KDE. Okay, kernel density estimate curve. It takes the distribution plot and it adds a smooth line to kind of illustrate our estimated kernel density there. Um, if you want only the kernel density estimate, you can turn that off. So you can do uh, here KDE equals true adds the kernel density estimate, but you can specify I want the kind of my distribution plot to be a KDE, and it will just be the kernel density estimate. Okay. Um, Another plot that we have is the estimated cumulative density function, or I'm sorry, cumulative distribution function, not density. And this is the CDF, but it's estimated based on the data. Okay. And so the CDF always kind of ranges from 0 to 1. And what we see, when you see the CDF have a sharp increase, that corresponds to many values in that region, and then when it flattens out, it means few values in that region, right? And um, so we can see, lots of values kind of in this 190, and then few values in around like 205. And that's what we're seeing here. Lots of values around 190, not very many values around 205. So it flattens out there. And so that's the cumulative distribution function. Um, and this is based off of the observed counts there. Okay. So handy if you're looking at one variable at a time. Sometimes you want to look at multiple variables at a time. So here, just to remind you what our data look like, we can look at flipper length and say bill length. Okay, so we're going to look at bill length and flipper length. Is there a relationship? All right, so dot dist plot, if you give it, so it's the same function here, but now we're providing two variables, x and y. Okay, and this is going to create a two-dimensional density uh, histogram, or I don't know what we call this, a density plot, where uh, no observations corresponds to basically white, light, a few observations in that combination, so like 180 and 30-ish. We have a few observations, and then dark would indicate we have a lot. So we have a lot of penguins with around 190 flipper length and bill length of around 41, 42. Quite a few observations there. Okay. Instead of having kind of this uh, diagram like this, you can say I want a KDE, and so now you'll get contours. Okay. And the contours here um, will reveal like, okay, we have a high concentration of penguins in this region, and we have a high concentration of penguins in this region with this flipper length, bill length combination. Okay. Um, you can also add a rug. Okay. Here, let me do rug equals true up to here. Okay. Uh, Takes a moment to process. And so here we just get like all of the different dots here, which is a little bit tough. Okay. One of the nice things here is you can specify the hue and have it correspond to a column. And in this case, we're going to have the color of our kernel density estimates and our rug and all of that correspond to the different species here. And so what this will reveal is, you know, the the shapes that we're seeing here, we saw kind of two concentrations and maybe even a third concentration here. These correspond to the different species of penguin. So the Adelie penguins have a lot of flipper length 190, bill length around 37, but the Gen 2 penguins have longer flippers and longer bills, okay? And the chinstrap penguins have shorter flippers but longer bills and things like that. And so we can see, this structure that we're seeing here actually consists of, our different things. And then we can also see the different rugs uh, being rug plot being displayed there as well. Okay. Um, Here without the rug, with looking just at one variable here, flipper length, we can see, oh yeah, this is the corresponding density plot for the three different species. Okay, compare that to when you just had one. Okay, uh, let me do kind equals. Okay, so our KDE, when you know we don't we see, okay, there's two peaks here, but it actually corresponds to um, three different species. Okay, this peak corresponds to one, this peak corresponds to another, and there's actually, the chinstrap penguin that just kind of ends up kind of blurring out the different things. So having um, having the hue tied to the species, reveals a lot of kind of the underlying structure here. All right. So these are plots that we can do in Seaborn. Oh, it's already 10:42. Okay, let me go ahead and give you your second view quiz answer, which is the letter A. A as an apple. A as an apple is your second view quiz answer. Um, okay. Here I've got kind of this histogram. You can also call hue equals species here, and then we're going to have different things. And so you have a few options. One is going to be multiple equals stack, and this is going to stack the different colors. And so you can see if you look only at the shape, right? Like if we were if we ignored the colors, the shape of these bars are exactly the same. But here we can see kind of the underlying numbers for all of these things. Okay. A joint plot, this is a nice, a pretty thing. We end up getting like all of the individual penguins get plotted as dots, and then we get the histogram, right? So this histogram, which corresponds to flipper length millimeters, is actually the same exact thing as this histogram, just kind of flattened down. It's just we take that histogram and we flattened it down to fit right there, okay? And you can imagine the same kind of thing for bill length there. And this was all done. Can I zoom out on this? Okay, I can't. Um, Maybe. All right. So this was all done with Matplotlib, and to try to do something manually like this with Matplotlib, oh my goodness, would be such a pain. Seaborn, thankfully, has done all of this kind of work, and you can create like a nice exploratory plot there. Okay. Um, you can also color by species, and it will color the dots by the species. So we do hue equals species, and we get that, and we get kind of the three different. Again, this corresponds to this kernel density estimate up here. This is the pretty much the exact same plot here, and so this is a nice thing, and yeah, you have that. Okay. And then KDE is going to replace, rather than the dots, you get the kernel density estimate. Okay. So Seaborn has a few like nice preset um, options that work quite well. Okay. Um, you know, uh, as much as I love ggplot, ggplot, you still have to kind of construct everything by adding layers on top of everything else. And there aren't very many like, oh, here's a pre-built template where you just kind of plug in the variables and you get exactly what you want. Okay. Whereas Seaborn is kind of like, okay, well, these are some of the kind of like template plots that we have, and I imagine somebody wants something like this, and you just kind of plug in the variables you want, and it produces that. Okay. Um, but yeah, that's that. And so you can always go on the internet and search Seaborn and look up like a gallery, Seaborn gallery, and you'll find a whole bunch of different plots that are out there. And you might say, "Oh, that's exactly the plot I want," and you use that. Okay. Um, all right. We're gonna have to kind of um blitz through some of these here. I've got the iris data, the pairs plot. We'll plot all of the different variables. So as far as the iris data set goes, there's sepal width, petal width, and it creates pairwise plots for each of these things. And then for like sepal length, you get your own kind of the histogram there. Um, you can take that and you can also color by species, and then that will reveal like the different species. There's three species of irises represented here, and so it's the same dots here, but just colored by the species. And you have Setosa, versicolor, and virginica, getting plotted there. Okay. Um, other plots. there's a data set called tips, and I don't, they recorded information about people who went dining and the tips that they left, and this must have been collected in the 1990s or something like 30 years ago or something like that, where the total bill for dining out was for three people dining out, the total bill was $10.34. So, I don't know how it maybe it was eating in the 80s. I don't know when they collected this data. But anyway, you have a few of these things. You have something called the strip plot, which is kind of like a dot plot. This is not very useful. You can jitter them so you have a little bit more spread. Okay, so this is total bill as split up by different day of the week and things like that. A swarm plot uh, is kind of like this, except it avoids overlap, and so all of the dots get spaced out so that the dots are not overlapping. This is what's called a swarm plot. You can also color them in by, different different variables and things like that. Um, if you have too many colors, as far as the colors goes, it's really hard. So here I said color the dots based on the day of the week, and we'll have, put on the x-axis male or female or something like that, the sex. This plot is really hard to read, okay? Um, This kind of data also lends itself well to box plots. So you have SNS Seaborn dot box plot, and we have this, and you can kind of split the box plot um, based on. So here, this will make the box plots horizontal, and all we've done is we've just swapped the X and the Y. Okay. And then you can also kind of create these side-by-side box plots by putting in a categorical variable tied to hue. Okay, so for whatever reason in Seaborn, rather than color, they use the argument hue, but that's gonna get get things like that. Okay, and then this this is called a violin plot, and a violin plot is kind of like you have a kernel density estimate for one side and a kernel density estimate for the other side. Not a huge fan of violin plots. I think box plots are superior, but if you wanted something that looks like that. Okay. You also have facet grids. So I'm just really kind of flying through these things. Okay. But basically a facet grid will take the same plot and subset your data based on some variable. Okay. So, for example, we can go back to our um, penguin data set. Okay. And we get under row. Okay. We can specify a variable, and this is going to create two separate plots, basically a faceted plot, where if we subset our data to the male penguins, this is what our distribution plot would look like. And if we subset our data to the female penguins, that's what we would do. Okay. You can also further do this, and you can specify row and column. And so I have row equals sex, column equals island. There's three islands in our data set. So we're going to get a grid of six plots, and we have the male penguins from the Torgerson Island and the female penguins from the Torgerson Island, the male and female penguins from Bisco Island, and the male and female penguins of Dream Island. And what this also reveals a little bit is, oh, the Adelie penguins, which are blue, show up on all three islands, but then, as far as the other species, they actually exist only on one of the islands each. Okay. Um, you can define a facet grid, but then you have to do facet grid, and then you have to do g.map. Okay. All right. So anyway, I'll let you explore these things. And so here, this is kind of it's a lot like this, but with facet grid in SNS, you can apply things that are not necessarily um, something from Seaborn. Okay, so here I can call plt.hist, which is just the default histogram function in Matplotlib, and so you can, if you really wanted the again, Matplotlib histogram function, in my opinion, is inferior to the Seaborn distribution plot. But again, if you had something specific, you can have it mapped across the different things there. Okay. And then just a little bit, you can do some exploratory analysis with like a linear model fit and things like that. And again, this can be split based on some categorical variable, and it will kind of create these things. These are exploratory in nature. You are not able to extract out like what is the slope and intercept of these things. It's just like, oh, if you fit a a a linear model, what would it look like? And this is what it would look like. Okay, we'll wrap things up here. Last view quiz answer is the letter D. D as in dog. D as in dog is your last view quiz answer for today. All right, thanks for joining me online. I'll have office hours online today, and yeah, we'll see you guys later.